In this section, guys, I'm going to mix the radicals, meaning set form, the exponential laws as well, Mandela rule. Just I give you more advanced sum, and then we take it further. Let's look at the first example. Your first example looks like this. You look at your root signs there, you look at the exponent 0.5, and then you have your Mandela rule there. Don't forget that. Even here, you have Mandela rule. But ultimately, we need to simplify this, guys. Don't say 128 plus 98. Remember, get this to set form, simplest set form. What I would do is finding the simplest form of 128 on the calculator separately. I put this equals, and I put this equals. This 0.5, guys, is you know that is half. Convert to half. I know that decimals are scary, guys. Take it to half, simple common fraction. And then this one, we just need Mandela rule straight away. Okay, let's see how we do that, guys. What I did here, if you look at that, it's a half, 0.5, I talked of that, Mandela rule here. Here, I want to put this separately on the calculator. That means square root of 128 and the square root of x2. I'm separating the variable from the coefficient. However, you can shortcut it to the answer. And again, I went further. 128 is 64 times 2. Remember, not using a calculator this way. Okay, not using a calculator, we know that we will always say without using a calculator. But if you put this in the simplest form and you still show your steps, no problem with that. And again, you can put this on a calculator or show the steps like this, 49 times 2. But what is important from that previous step is this one. From that, you can move to that. Therefore, it's where you'll get your marks. We're just trying to show you that we didn't get this from heaven. It came from 64 times 2, meaning 128. And you're still keeping your halves there. And then here, square root of 49 times square root of 2. But when you take it out using a calculator, you're going to have this. This is what you call simplest set form. This is set form, but they are not in their simplest form. Okay, now, if you look at the top, I see like terms. Okay, and then don't be tempted to cancel or to cross cancel whatever you're dividing here because of addition here. So at the top, let's see. When I go 8 root 2, from here is your like term. From here, root 2 x cubed. You just go 8 plus 7. Then it gives you 15 of root 2 of that. You just simply add those. Or just put these numbers only on the calculator. Be clever. Put these numbers only, but you still show your step that is 15 root 2 x cubed. And then the bottom one, remember to exponent half. Mandela rule. If we are to reverse the Mandela rule, we'll have square root of 2. Okay. Then what happens now? Your division now. Division, simple division here. So you get 3. Why? Root 2 will cancel root 2. 5 into 15 goes 3. X cubed over x squared using the exponential rules of subtraction there, you get x. Cool. And looking at another example here. Guys, this looks complicated, but not. If you look at this, I'm going to change this root sign. I'm going to take the cap off. Remove your cap, guys. Remove your cap by Mandela rule. Then it's 3 over. What did you get this 2 from? There is always invisible 2 there. You can't see it, but it's there. Then I divided by it. The same thing there. Now, what do I do? Because not like terms. 3 over 2 and 5 over 2 not like terms. And I cannot divide. So why don't I factorize? Okay, guys. Now we factorize the top and the bottom. Okay. Now 3x to 3 over 2 is a common factor to it. All right. We have this brackets and we have x to 5 over 2 as common factor underneath. Remember, your main fraction is here. Then you have this. Now this can cross this out or it can divide into that. Let's do so. And then we have x to 3 over 2 remaining divided by x to 5 over 2 remaining. And then what happens now? Look, simple rule. I know that you're scared of fractions, guys, but why should you? Stick to your rule. What does the rule say? The same basis, cool. They're the same, x and x. The top exponent minus the bottom exponent. This is the fundamental. It's what I'm going to do now. And let's see. I know that you don't like fractions, guys, but stick to your rule, and your calculator can always help you. But don't just rely on your calculator. Do steps. Then each time you need like 3 over 2 minus 5 over 2. Yes, put this on a calculator. If you need 3 over 2 minus 5 over 2. Don't just rely much on the calculator. And then what does it give you? It gives you x to negative 1. Should we leave it here? Because it's the final answer. I know under pressure, under formal setting of your exam, you may leave this here, but that is not actually, guys, satisfactory. Take it further and make this a positive, meaning equals 1 over x. Guys, nothing new. It's a matter of building the sum up, building, overlapping into complex procedures, your level 3 and your level 4. But you still apply the knowledge you have about the exponential rules. Nothing new. It's the matter of concentrating, figuring out the sum deeply. On this note, guys, see you in the next lesson. Cheers.